Dear students, welcome and thank you for tuning in to this video. I am Dr. Loay Al-Zube. I am still creating a series of videos about biomechanics. We'll continue our discussion about the biomechanics of human skeletal muscles. So in the previous lecture, we talked about what are the basic behavior properties of the musculotendinous unit. In this video, I will talk about how skeletal muscle function to produce coordinated movement of the human body, and then I will follow that with another video about what are the effects of the force, velocity, and length tension relationships, and what is the electromechanical delay of muscle functions. I will focus in this video on how skeletal muscle function to produce coordinated movement of the human body. It's really interesting topic, and I hope that it'll be helpful. Please watch the video in its entirety so that you don't miss anything. So the first thing I want to talk about is the torque. We know what is torque. Torque is the force multiplied by the distance, which is the perpendicular distance between the point of rotation and the line of action of the force. Muscles are the physiological unit that produces force. So the torque of the muscle at the joint center of rotation is the product of the muscle force, or FM, F muscle, and the muscle moment arm, which is the perpendicular distance between the point of rotation and the line of action. And here it's D, and you can see that it has this sign of the perpendicularity as a subscript of it. So this is the first thing that we need to keep in mind, and it is coming back to us from statics and dynamics, the concept that we learn in statics and dynamics. So this is a very important functionality of muscles, that they produce torque, which result in moving the skeleton of the human body. The other thing that I want to talk about is how motor units in general are recruited. If you recall from the previous lecture, we talked about fast twitching and slow twitching motor units. And if you look at them, first image at your left bottom corner is the definition of a motor unit. The motor unit consists of a neuron and all the innervated muscle fibers that the neuron is connected to. And if you recall, a muscle fiber is one cell, is a muscle cell, and it's multinuclei. Then we talked before about the fast twitching and slow twitching, and that is the image in the middle, the bottom part of the screen in the middle, where you can see that the tension developed in the fast twitching motor units, which is the dashed black line, and the slow twitching motor units, how they're recruited with respect to time, and this is in the blue line. So usually slow twitching motor units are easier to be activated than the fast motor units. So because of that, the slow twitching motor units are the first to be activated and recruited in any movement. So as the force requirement increase and the speed requirement increase and the duration of the activity increase with your motor tasks or whatever activity you are doing, motor units with higher thresholds are progressively activated as you progress in your motor task or whatever activity that you are doing. So this is another important concept about skeletal muscle function that you need to be aware of. So we first recruit the slow twitching, then the fast twitching motor units. Another thing that, continue on the our journey in identifying the jargons and the terminology used in analyzing skeletal muscle function. So we use terms to describe muscle contractions based on the change in muscle length. So we have three descriptions. So the first one is concentric, then we have eccentric, and then we have isometric. So if you look at the image to your right, the first thing, isometric contraction is when the muscle contracts but it does not shorten. So that's involved no change in the muscle length. So you can hold, let's say, a dumbbell, and if it's if you can see the angular of your upper arm and the forearm, your biceps, let's say, is in its resting length but it is creating tension to hold the dumbbell. That is called isometric. Now, if you have shortening of the muscle, and that is in the image, that is B, section B. So this is concentric, and if it's involved lengthening of the muscle, that's eccentric contraction. So we need to keep these in mind, so to know what is isometric, what is concentric contraction, and what is eccentric contraction. Remember, all of those, you have the muscle active actually, and that it is producing force. That's why we are holding the dumbbell, so that that it means that there is force produced and created, and there is some contraction, because but at different lengths of the muscle. That's another important concept to keep in mind. The other thing that I would like to mention is that we have roles assumed by muscles, and so we characterize muscles to be agonist, antagonist, stabilizer, or neutralizer muscles. And the agonists are the muscles that act to cause movement. Antagonist acts to slow or stop the movement, and an example of these two is the biceps and the triceps. And I've described this. I will also describe it more in following videos. But if you are going, doing flexion and extension, in your flexion, your biceps is your agonist muscle, and your triceps is your antagonist muscle. That's something to keep in mind. Now, stabilizer muscles act to stabilize a body part against some other forces, and stabilizer muscles work to stabilize the body and its extremity during multi-plane movement. That's important. And during an exercise, there are primary movers and stabilizer muscles. So we need to make, so if you are holding your hand, similar to what the image to your bottom right is showing, the subject is showing, you need a stabilizer muscle to hold the shoulder grid in place, so the deltoid can pull the humerus up. That's very important. So while the stabilizer muscles aren't directly involved in the moving the load, they work to keep certain parts of the body stable and steady, so the primary movers can do their job efficiently. There are a lot of examples that you can look at. The neutralizer muscles act to eliminate any unwanted action produced by an agonist, acting muscle. And if you can see by, in the image as well, holding the hand horizontally, the neutralizer is active. Then the shoulder will, if it's, tends to internally rotate. So the minor can be used to counteract this via its ability to externally rotate the shoulder. It makes sure that we have a stable movement and stable structure when we do any motor task. So you need to know that these are the four roles. Now, stabilizers, it's not actually a type of a muscle. Muscles can be agonist and can be stabilizer. So it's a role. And to an extent, so you don't have 100% stabilizer, but all our the muscular system is connected in such a way that you need a lot of muscles to interact and together in order to perform a specific motor task. So that is something to keep in mind. Okay, now I would like to go into there's another important concept in muscle function, which is two components, or two how do you, it's there are two functions or two activities or two characteristics of muscle function, which are active insufficiency and passive insufficiency. So I can say that. So active insufficiency and passive insufficiency. Sorry. So what are the disadvantages associated with the function of two or multi-joint muscles? As I mentioned before, in order to perform any motor task, there are multiple muscles involved, and those muscles are connected to multiple joints. And because of this fact, we have some kind of disadvantages associated with these multi-joint muscles. So this is termed in active and passive insufficiencies, and I would like to explain them a little bit more. So I will start with passive insufficiency. So it is an inability of a two-joint muscle to stretch enough to allow full range of motion at both joints at the same time. So if you look at, and for example, if you flex your forearm and try to flex the fingers at the same time, try it. So this is you. If you can look at this in the image at the top left. So if you flex your forearm, you can see that you have a specific angle. Now, if you try to flex your fingers at the same time, you can see that the angle increases because your back part of your hand the dorsal part of the hand is increasing, is going up. So you cannot actually flex both of them and have the same angle at that joint. And this is called passive insufficiency of the extensors of the forearm. And so in this situation, extensors, they are both extensors, they are not long enough to do this type of action. That's what we call passive insufficiency. It's passive because it depends on the lengths of the extensors, the muscles, and there's nothing to do. We can't do anything about this, and that's a limitation or a disadvantage of a multi joint muscle. Here you have the extensors that they are connected to the wrist as well as your fingers. On the other hand, active insufficiency, it's a condition that's occurring when a two joint muscle cannot shorten enough to cause full range of motion at both joints. It crosses. So an example of this active insufficiency is the wrist flexors. And so you have a decreased ability to form a fist and also even to squeeze on a soft ball or anything when you have your when you have your hand actually flexed. And when the wrist is fully flexed, because of the sacromeres runs into each other, leading to inability to musculature to contact, or to contract more, actually, because your sacromeres are, the myosin and filament, they're all shortening on top of each other. So we don't have more room to do more flexion, right? And you cannot even squeeze. So if you did the flexion and you try to squeeze on a ball, you cannot, because of what is active insufficiency, in which that the sacromeres are very close to each other in the wrist flexors, and they can't perform any further contraction. And that is what we mean by active insufficiency. I hope that all of these so far, what I mentioned about them, skeletal muscle functionality and the terminology used in this regard is helpful. Please watch the following video. Thank you for watching, and till next time. Bye.